Let's look at the second example this time. And it looks like I have the whole page to do this. Well, not really the whole page. All right, so example 2. For the following function, give the coordinate of any critical points. To find the critical points, we first find the first derivative. What is g prime of x? That is 20x to the third power plus 60x squared, isn't it? Yep. So to find the critical value, set it equal to 0. I can see that I can factor out 20x squared from both of these terms, and I'll have x plus 3 left. I'm just doubting myself. I just want to make sure that I factored it right. Let me distribute it back in to see if that was right. Looks good. Okay, so keep going. I think that's as far as a factor. So x equals either 0 from this term, or x equals what? -3. So these are the critical values. We found them. Critical values. Not only that, they wanted the critical points. They wanted critical points. So what I need to do is I need to plug these in, x values, into the g of x. What is g of 0? That is 0, 5 times 0 to the 4th power. Oh, hey, that's just going to be 0. So the first order pair is going to be 0, 0. And the second y value, if I plug in -3, and I'm going to need a calculator for this piece. All right, what is that? And I got -135. So 0, 0, and -3, -135 are critical points. Now, the second part is that they want us to classify each point as relative maximum, relative minimum, or neither. Okay, so what do? We're going to use the second derivative test. I don't want to write, let's write down, let's do the second derivative test, which means I need the second derivative. So take a look at your first derivative. I don't like that color. And then we're going to take the derivative of that so that we can use. So g double prime is 60x squared plus 120x. So we're not setting this equal to 0. That's for concavity later. That's for point of inflection later. Right now, we're going to plug in the critical values. So plug in x equals 0 and -3 to find their signs, okay, to see if it comes out to be positive or negative. So first, if I plug in 0, oh no, that's going to be the yucky situation, you guys. Guess what? Second derivative test failed. It needs to come out to be positive or negative. So what we are going to have to do is we're going to now have to go and do the first derivative test, which means I need to now look at the sign to the left and sign to the right of 0. Okay, so we'll do that real quick, and we'll come back and do the other critical value. So now I'm using, use the first derivative test here. The first derivative is g prime of x equals 20x squared times x plus 3. Let me zoom in for you. So if I plug in a number that is bigger than 0, I'm thinking 1 is perfect. If I plug in 1, what will that be? 20 times 1 squared times 1 plus 3. I can tell this is going to be a positive number. So this will be increasing to the right of 0, right? Now I need to plug in a number that is smaller than 0, which is -1. I'll use -1. So what is f prime of 0? That will be 20 times -1 squared times -1 plus 3. That is 20 times 1 times 2. Well, that's a positive number again, right? So this is increasing to the left. and increasing to the right. And if you remember about the multiplicity of this graph right here, well, I guess probably not a good idea to talk about multiplicity of them. Well, I'll just go ahead and stick with calculus here. So if it's increasing to the left and increasing to the right, is this a relative minimum or relative maximum or neither? Well, this is just neither. So when the second derivative test failed, I came back and tried the first derivative test. Well, the first derivative test also didn't find this x equals 0 to be a relative minimum or maximum, because it was both increasing and increasing to the left and right. So, well, unfortunately, we're going to have to just say that 0, 0 is not a relative minimum or relative maximum. It is a critical value, but it's not a maximum or minimum, because the increasing, or it didn't change. I mean, it was still increasing to the left and right a bit. So now let's move on to the second guy. The second critical value was -3. So let me now plug in -3 into the second derivative. What is g double prime of -3? Well, that is going to be 60 times -3 squared plus 120 times -3. I'm going to type this into my calculator, and it comes out to be 180. Well, yay, this is a positive number. This is positive number, which implies that -3, -135 is a relative. I guess I can get rid of a. This is relative what? Positive, so minimum. So unfortunately, 0, 0 was neither, but at least -3, -135 was a relative minimum. So did they ask us to graph it? No, they didn't, but they do want us to find where this is increasing or decreasing. So that's another whole page of work. So let me just try to do that over here, okay? So now I'm going to go ahead and just sketch a quick picture. I will say that I have a point 0, 0 and another point that is at -3, 3 to the left, and then my graph is completely out of scale. That is okay. I'll just say this is -135. I'm going to zoom in so that you can see. I'm sorry. So this point right here, -3, -135, this is a relative minimum. This is relative minimum. I wish I had more room. I should have put more room. But 0, 0 wasn't anything. So if this is a minimum, what I know is the graph will be decreasing to the left and increasing to the right, right? It's going to keep on increasing until it hits a 0. And remember what happened. It still increases, right? It kind of stops for a second with the concavity of 0. I'm sorry, not concavity. With the first derivative of 0. So it's going to keep on increasing again. So the graph will look something like this. Okay, so where is it decreasing? So I'll say G is decreasing on -infinity to this value right here, right? -3, and G is increasing on -3 to 0 and 0 to positive infinity, or I think in my lab they want you to just write it as -3 to positive infinity. That's what I think I noticed when I was looking at your homework. Instead of cutting this in 2 different intervals, you can just, I guess, write it as a combined interval. But that's enough. That is enough for example 2. We answered every part of it. This one was a little more challenging because the second derivative of our first critical value came out to be 0. That's why I had to bring in the first derivative test. But that was the only little bit challenging part. Everything else was okay. I will come back and show you the concavity and how to find point of inflection in another video.